So this video lesson is all about the perimeter and area of rectangles and squares. Now, in large part, I think this video lesson will be a lot of review, but we will start off by talking about what perimeter and area are. Then we will get into perimeter and area specific to rectangles, specific to squares, and of course at the end we'll have a few practice problems for you to work on. So the first question that we need to answer is, what are perimeter and area? Before we can talk about them specific to rectangles and squares, we have to make sure we understand what they are individually. But the easiest way to talk about perimeter or area is to do that in the context of a specific shape, so we can see a concrete example of it and then generalize out to what we need to talk about. So let's take a look at this rectangle here, and we want to figure out what is the perimeter and what is the area. Well, if we imagine the rectangle is a walking path, and we start in the upper left-hand corner, and then we walk down the side, across what in this case is the bottom, up the other side, and then back across, completing one full lap around the shape. We have just walked across the entire distance of all the sides that make up the shape, and that is what perimeter is. Perimeter is the distance around the shape using the sides, or the sum of all sides. So in this case, we can see it easily just by walking around the rectangle, again, down the left-hand side, bottom, right-hand side, and across the top. That is the perimeter. The area of any shape, and this rectangle specifically, is the amount of space that is covered by the enclosed shape. So whereas the perimeter is a distance, the area talks about, and let me pull up a highlighter here, the area talks about all of this space here. We fill this all in. I know it's not perfect, but that is what's talked about by the area. So the area then is just the space that the shape covers, the area covered or enclosed by the space. So now let's look at those two things specific to a rectangle where we talk about length and width and those sorts of properties of the rectangle. So first, every rectangle has two sides that are parallel, which will be in blue, and another two sides that are parallel, which will be in purple. Now, these two parallel sides that are blue happen to be longer than the purple ones. Generally, for the sides that are longer, we call that the length of the rectangle, although any side technically could be the length. And because of the definition of a rectangle, two sets of parallel and equal sides, we know that not only is the top side of this one the length, we know that the bottom side is also the length. And then, of course, two parallel and equal sides, the two sides on the left and right. One we could call the width, and we know that the other then must also be the width. So now we want to talk about what it means to look at the perimeter of a rectangle. And so let's look at it the way we did the original rectangle when we talked about perimeter. We start at the upper left-hand corner, and we walk down the left-hand side. What we see is that we've now covered a distance equal to the width of the rectangle. So I'll include that down there. Now we're going to walk across the length, and we've covered a distance equal to the length of the rectangle, because that distance is now the width of the left-hand side and the length of the bottom side. Now if we walk around the rectangle on one more side, we've gone once again a distance of the width. And finally, looking again at the final side that we have to walk through, that distance is the length. So our perimeter, the distance around this rectangle, is the width plus the length plus the width plus the length. And we'll notice that we have two lengths that we're going to add together and two widths that we're going to add together. And this really is the more common formula for the perimeter of a rectangle. Not length plus width times length plus width, but rather 2 times the length plus 2 times the width. You can also see it sometimes written as 2 times the length plus width, because we are more or less going across the length and width once, and then the length and width again. So now for an area, we want to find the amount of space enclosed by this shape or covered by this shape. And it turns out that the formula for the area, without going into the breakdown of squares that are covered by the rectangle, are just the length and the width multiplied together. So length times width. Now these are the formulas for a rectangle: 2 times the length plus 2 times the width, and length times width. And now we want to move on to what it means to find the perimeter and area of a square. Now a square is just a special type of rectangle. It is a special circumstance in which all of the sides are the same length, but a square is just a type of rectangle. So the perimeter and area formulas that we're going to use for a square are based on those of a rectangle. Now instead of plugging the side length into the perimeter formula for a rectangle, for a square, we're just going to look at the sides and more or less walk around the shape like we did before. Again, starting in the upper left-hand corner, we go through a side length, because they're all the same, once, twice, 3 times, 4 times. So the perimeter of a square is just 4 times the length of a side. Now if we plug the length and width for the area formula of a rectangle with the fact that all of our sides are the same, the area of this rectangle is just the length times the width. Well, the length of this square is the side. The width of this square is the side. And as you remember from the lesson on powers and exponents, this then is just the side multiplied by itself twice, or the side squared. So the perimeter of a square is 4 times the side, and the area of a square is side squared. And these are both based on the area and perimeter formulas for a rectangle, because, as we mentioned, a square is just a special type of rectangle. Now let's see 2 examples of how to go through these formulas with specific rectangles and squares before we go off to problems on your own. So for the rectangle on the left, we want to find both the perimeter and the area. Well, the perimeter is 2 times the length plus 2 times the width. The length of this rectangle is 14. Put that in parentheses there. The width is 5. 2 times 14 is 28. 2 times 5 is 10. So we have 38 centimeters. Remember, for perimeter and area, we always want to have units. Now, the area, I'm going to move down the page here a little bit. So for the area, we need to find the length and the width, but then multiply them together, because that, after all, is the definition of area. So the length of this rectangle, as we said before, is 14. The width is 5, and 14 times 5 then is 70. But because it's an area where it's not just a distance, it can't be a centimeter, we have multiplied 2 centimeters together, so it is centimeters squared, or square centimeters. Now if we go up to the square, the length of the side of the square is 8 inches. So our perimeter is going to be 4 times the side length. Because the side length is 8 inches, our perimeter then becomes 32 inches. Now when we are looking at the area, our area then is the side squared. The side is 8, so the area is 8 squared, or 64 square inches. And so those are 2 examples of how you use the perimeter and area formulas for a rectangle and a square to find the actual perimeter and area measurements. So go ahead and pause the video, take a look at these 4 problems here. 2 rectangles and 2 squares. See how you can do to find the perimeter and the area. If you need to go back and take a look at those formulas again, feel free to. But as soon as you're done with these 4 problems, go ahead, unpause the video, and then we'll go over them. So let's look at the rectangle in the upper left-hand corner, which we'll call problem 1. The perimeter, again, I'll write these up here. The perimeter is 2 times the length plus 2 times the width. So in this case, the perimeter is 2 times 11 plus 2 times 4. 2 times 11 is 22. 2 times 4 is 8. So our perimeter here is 30 miles, rather. Let's take a look at that and get rid of this. Is 30 miles. Now the area then is just length times width. Our length times width is 11 times 4, or 44 square miles. Looking at number 2, which we'll say is the square with a side of 24 centimeters, if we're going to look at the perimeter of that square, we would have to look at 4 times the side length. The side length is 24. So our perimeter is 96 centimeters, 4 times 24. And then our area is just the side squared, which is 24 squared, which of course is 576 square centimeters. Now if we look down here at the square in the bottom left-hand corner, which we'll call number 3, again the perimeter is 4 times the side. The side is 15 inches, so perimeter then is 60 inches. Our area is side squared, which is 15 squared. So our area then is 225 square inches. Finally, we have the perimeter and area of the rectangle, length of 7 kilometers, width of 16 kilometers. Our perimeter is 2 length plus 2 width. Our length is 7. Our width is 16. So 14 plus 32 is 46 kilometers. And finally, our area is length times width. The length is 7, the width is 16, and 7 times 16 is 112 square kilometers. So again, as a matter of review, the perimeter is just the length around a shape, as if you were walking along the sides across the entire length of the shape. And the area is the area covered by the shape. So for a rectangle, the area and perimeter formulas, perimeter is 2 times the length plus 2 times the width. The area is length times width. And for a square, the perimeter is 4 times the side, and the area is the side squared.